Hello again, this is Professor Watts, and today we're going to talk about what I label Ricardian economics. And of course, we're talking about the great 18th century English economist pictured on the left, not the famous TV character Cuban drummer. And just a brief note on Ricardo. Here I have the Wikipedia entry on him, and you'll notice here it says his most important legacy is his theory of comparative advantage. Ricardo did a kind of math that's similar to what we're going to be doing, but I've restructured it in a way that I think works a little bit better. It's a little simplified, but we're basically doing the same exact kind of reasoning and logic and mathematics that Ricardo did about 200 years ago. We're building on, remember, in lecture 4, Adam Smith's idea of specialization being one of the great drivers of the wealth and prosperity that he observed in the 1700s and that we've seen just flourish even more so since then. And today we're adding to that concept of specialization the concept of comparative advantage, which says that specialization is powerful for everybody, even if you're not particularly good at anything. To understand comparative advantage, we need to understand absolute advantage, and we're talking about productivity, how good someone is at producing a product or doing a task. And the key to understanding the comparative advantage is that you don't have to be the best at something. You can be pretty good at something, but not the best and still have a lot to contribute. Or you can actually not be really good at anything. You'll just find what you're the least bad at and you'll still be able to contribute. And the world will still be able to achieve more production and more value and more wealth creation through specialization plus trade. On the plus side, comparative advantage says focus on what you do more better. On the negative side, even if you're not better than anyone else, even if you don't really have many skills to speak of at all, that's still okay. We'll talk about focusing on what you do less bad than anyone else. Okay. So how do we think about what you do more better and less bad? Well, we have this idea here of a skill meter, and we can actually measure people's productivity. We can measure it in how much time it takes you to do a particular task, or we can measure productivity for a whole country or economy in terms of how many dollars it costs to produce a particular good. But we'll start off with a very simple concept of measuring productivity in terms of time. Okay, and the best example I have from my own experience is playing Legos with my kids. So you have to understand first off that I'm a huge Lego buff, and I've been playing with Legos since I was a little kid and never threw any of them away. I always kept them. And I accumulated over the years a large collection to which I am still adding. And when my kids were little, they spotted my big Lego bin and they wanted to play with them. And at the time when they were old enough, when I could trust them not to swallow the pieces or lose the pieces down the heat ducts in the house, I said, okay, it's time. We've got the the tub of Legos down, and I got out a file folder of instruction manuals, and I said, what do you want to do? And it looked a little bit like this. This is a slight exaggeration, but what we're looking at is a tub full of thousands and thousands of pieces from all kinds of different Lego sets. And I had some space sets, I had a lot of pirate sets, I had castle sets, I had city with the fire department and that kind of thing. So there's a lot of options and all the pieces are mixed together. And I showed the kids the instructions and the pictures of what we could build, and one of the first things they were interested in was the castle. So I got the castle instructions out, I said, okay, let's go to work. So for those of you who have played with Legos or still do, you know that there's two main tasks in building in this way. First off, you have to find the pieces you need for that particular set. So of all the pieces in there, we've got to find the gray castle pieces. Of all the firehouse pieces, of all the space shuttle pieces, of all the pirate ship pieces, we've got to dig through and only get out the gray colored castle pieces. Okay, so that's the search task. Once we've done that, comes the build task. We've got the instructions here, and we put those gray castle pieces together in sequence. So let's think about the comparative skill levels, and here's my skill meter. Here I am, a Lego expert, and I'm pegged out on my skill meter. My skills in search and build are both at a 10 out of 10. I have decades of experience, and I'm very good at it. Okay, and there's my daughter. She's the oldest, and she was the first of my kids to experience the joy of Legos. And at the beginning, her skills are pretty weak. She's less than a 2 in search and not even a 1 in build because she has no experience. She hasn't played with them before. Okay, so what can we say about this? And you might be looking at this and say, wow, the daughter, she has nothing to offer. She has no skills comparative to you, Dr. Watts. She's got nothing. How can she contribute? Well, remember, comparative advantage says think about what you're more better at or what you're less bad at, and not about the absolute skill level. So let's compare the skills. I'm 6 times better at search. Okay, my skill of 10 versus her skill of less than 2. It's a multiple of 6. But I'm 25 times better at build. Okay, my skill level of 10 versus her skill level less than 1. So I'm more better at build. And that, of course, means she's less bad at search. Her skill level is 1/6 of mine in search, but 1/25 in build. So she's less bad at search. I'm more better at build. So in comparative advantage, what we'll do is I'll tilt a little bit of my time or my resources to doing more build and less search, and she'll do more search and less build, and potentially only do search because her build skills are so weak at the beginning. And we will indeed, with the same amount of resources or the same amount of time, we'll be able to achieve more production in terms of building Lego sets than either of us would individually with the same amount of resources or time. I'll prove that to you mathematically here in just a minute. And then if we trade, if we specialize based on our comparative advantage, and then trade our surplus output with each other, we're both going to be better off. We're both going to have more output. So what's going to happen is that my daughter's going to specialize in her less bad task. I'm going to specialize in my more better task. And together we achieve more. We put these pieces of the coordination puzzle together and have a more prosperous economy. Let's get into the math on this. We're going to calculate the opportunity cost, which means what did we give up by doing each task? Remember, economics is all whenever we talk about cost in economics, it's always opportunity cost. So we want to start there, and when we calculate opportunity cost, that'll show us where each of our comparative advantages lie. Okay, so first off, there's the 2 tasks. There's search, and I'm measuring cost now in time per piece. And we've talked before about time is kind of the ultimate resource. Time is a scarce resource. The time has to be used up in any production process. So here we'll strictly think about the costs in terms of the time it takes. And let's say my search time is 10 seconds per piece on average, and my daughter's is 60, and that comports with the ratios I established earlier. Okay, and then my build time per piece is, let's say, 5 seconds. So you see I'm more better at build, and hers is 120 seconds. So I'm way better at both tasks in terms of the time it takes me, but I'm more better at one, here where my time is lower, and she's more better at she's less bad, we should say, at the other, where her time is lower. So we would say I have the absolute advantage at both tasks, but specialization and trade and economics is really not about absolute advantage at all. Okay, you want to know the definition of this. Absolute advantage is about whoever has the lower input cost or resource cost, and here the input or resource we're using up is time. But economics is not really interested in that. It's interested in comparative advantage, and to understand comparative advantage, we'll have to think about opportunity costs. Okay, and remember, I'm 6 times better at search, but 25 times better at build. So I'm more better at build. She's less bad at search. Now let's calculate opportunity cost. Okay, and I hope you remember the definition of opportunity cost. If I'm doing activity A, opportunity cost says how much of activity B do I give up to do activity A. Well, let's say this is activity A, search, and this is activity B. So if I'm searching, how much building do I give up? Well, it takes me 10 seconds to search for a piece. In that 10 seconds, how many pieces could I have built? Well, at a ratio of 10 to 5, I could have built 2 pieces. Okay, so I just divide my search time by my build time, and that's my opportunity cost of search. And I should really label this 2B. It's two pieces built, or I could say 2 pieces. My daughter's opportunity cost of searching, in the 60 seconds it takes her to search, how much build could she have done? Well, at a ratio of 60 to 120, it's only 1/2. Okay, so her opportunity cost of searching is only giving up 1/2 a piece being built. Okay, so we see that she has the lower opportunity cost of search. Now let's think about opportunity cost of building. And now we're saying if I'm doing activity B, how much of activity A do I give up? Well, for me, it takes me 5 seconds to build. In that time, how much search could I have done? At a ratio of 5 to 10, I could have done 1/2 unit of searching. I could have found half a piece in that time period. And for the daughter, it's 120 seconds spent building. how much search could she have done in that time frame at a ratio of 120 to 60. You see that it's 2. Okay, so now we'll look for who has the lower opportunity cost of building, and that's me. Okay, so the costs that matter are opportunity costs. My opportunity cost is lower for building, so economic wisdom says I'll focus on that more. Her opportunity costs are lower for searching, so she'll focus on that more, and then we'll trade our output, and together we'll have a lot more production in a given time period with a given amount of resources. Okay, so there's the lower opportunity cost for search, the lower opportunity cost for build, and now we have some guidance on what we're going to specialize in. And then all that's left to do is to prove that with specialization, based on our comparative advantage, we will achieve more than we would individually in the same amount of time. Now, to prove the gains we get from specialization based on our comparative advantage in trade, I want to work through a scenario where I give a fixed amount of resource, and remember the resource here is time, and compare working alone versus specialization based on comparative advantage. So here in the top row I have working alone, and I've divided up the 2 tasks, search and build, dad and kid, and we'll see how much total production we can get by adding everything up. I've got an hour. I'm fixing this at 60 minutes of total time, so 60 minutes for me and the same 60 minutes for my daughter to work, and see how much we can produce in terms of building Lego sets. Okay, now if I'm working alone, I want to search and build the same number of pieces, and because my ratio of time in search to build was 10 seconds for search and 5 seconds to build, so it's a 2-to-1 ratio, I've got to spend my time in a 2-to-1 ratio. So I'm going to spend 40 minutes of my hour searching and 20 minutes building, and 40 minutes is 2400 seconds. At 10 seconds per piece I get 240 pieces. 20 minutes is 1200 seconds. At 5 seconds a piece I get 240 pieces, and I build 240. Okay, so my output is 240 pieces worth of Lego sets built. And what does my daughter accomplish? Her ratio is the opposite of mine. It's 1 to 2, because it takes her 60 seconds to search and 120 seconds to build. So she's going to work at the opposite ratio. So she's going to spend 20 minutes searching, and that's 1200 seconds divided by 60. She finds 20. And 40 minutes building, 2400 seconds divided by the 120 seconds per piece. She builds 20 pieces. So altogether, I search and build 240 pieces. She searches and builds 20 pieces. Altogether, to add those up, 240 plus 20, we search and build 260 pieces. That's working alone. Let's see if we can crank that output up the same amount of time. Okay, I'm not cheating. I'm not giving us more resources, more time, more technology, anything else. We're going to go with the same search cost, the same build cost, but we're going to specialize in our comparative advantage. Remember, I'm more better at build, so I'm going to tilt more towards build. She's less bad at search, so she's going to lean more towards that. And let's think about a scenario where we can achieve more together. Okay, and that's what we're doing down here in the second row, specialization plus division of labor. Now, I want to be able to build all the pieces that are found between me and my daughter. So I worked out these ratios so we wouldn't have any extra pieces that we search that don't get built. So I worked out that if I move just 3 minutes and 20 seconds, if I shift 3 minutes and 20 seconds out of searching and over to building, okay, so I'm plus 320 over here on build. I go from 20 minutes to 23 in 20 seconds, and I'd go down the same 3 minutes 20 seconds in search. That lets me search for 220 pieces and then build 280 pieces. Okay. Now, I'm not searching for all those pieces, but I can build them all, so who's going to pick up the slack? Well, of course, my daughter. And because her skills are so low, she's going to focus only on search. She's going to spend her whole hour searching. So 60 minutes, which is 3,600 seconds, at a rate of 60 seconds per piece, gets her 60 pieces, a minute per piece. So she finds those remaining 60 pieces that I couldn't find, and I build them all. She spends 0 time building. And voila, together we achieve more. We bumped our output up from 260 to 280. That's plus 20. And percentage-wise, let's divide that by 260. And that works out to about a 7.7% gain. That's a productivity gain of 7.7. Now you might be thinking, now that's paltry, but that's not. That's actually a huge gain because all we did was rearrange the resources we have. We don't have more resources, we don't have more skills, we don't have more technology. Just based on rearranging what we have, we got almost 8% more stuff. So that's a free gain. That's a miracle. That's like magic.
Watch me pull a rabbit out of my hat. Bah! See? Nothing up my sleeve. Presto!
Okay, so there's our mathematical proof that specializing in our comparative advantage gives us more output. Now, the moral of the story here is that everyone is the low-cost producer of something. So even if you don't have many skills, you have a cost advantage in terms of opportunity costs. You have a comparative advantage that you can use to contribute to the world economy and a higher standard of living. Okay, so now let's move on and apply this to a somewhat more real-world situation. And this is a textbook model from a book I use in the class. And it's really basic, but nonetheless, it's a good reflection of realities and the key facts, and that's all we want in a model. We want it to be as simple as possible while still reflecting reality at some fundamental level. And we're basically divided the world up into two countries, United States and Mexico, and two goods, computers and shirts. Okay. Now, and then we've got the labor units required to produce computers and shirts in each country. Okay, and what do we see here? Mexico takes 12 hours to produce a computer and 2 hours to produce a shirt. You can also think of this as kind of the number of workers. You could think of it as time or units of an input. The results are going to be the same. So it takes them 12 workers to produce a computer, 2 workers to produce a shirt, whereas the U.S. only takes 1 to produce a computer and 1 to produce a shirt. The U.S. is more productive in everything. The U.S. has the absolute advantage in computers, the absolute advantage in shirts, but remember, absolute advantage is not what's relevant in economics. Comparative advantage is what's relevant. So before we even do any math, you can probably just look at these numbers and the ratios and say, what is the U.S. more better at? Which one of these is the U.S. more better at? It only takes 1/12 the labor to make a computer, so the U.S. is more better here. Okay, then therefore Mexico is going to be less bad here. And what we're going to do is mathematically prove that if the U.S. specializes in computers and Mexico specializes in shirts, we're going to have more, and then we're going to be able, through trade, to trade off the surpluses, and each country can consume more of each good. It's a beautiful thing. Okay. And again, the model is kind of reflecting on the fact that we've got the U.S. is kind of a high-tech, high-skilled country. So that's what we're reflecting here. The world is much more complex. There's not just computers and shirts, and of course within computers there's there's tablets, there's laptops, etc. But think of this as this is a category that represents your higher tech products and therefore your higher skill labor. And then shirts is a category that represents kind of lower tech products and therefore lower skill labor. Okay, this is representative of a generalized reality. Okay, so first off, we want to calculate opportunity costs. The opportunity cost of a computer is how many shirts we could have made. In Mexico, it takes 12 workers to produce a computer, but only 2 to make a shirt, so the ratio is 12 to 2, and that's where we get the 6 shirts. That's the opportunity cost of computers. And then it's 2/12, so the reciprocal of the opportunity cost of computers. Okay. Now for the U.S., it's really easy. With the 1 worker or 1 hour of labor that it takes to make a computer, we could have made 1 shirt, and vice versa. With the 1 hour it takes to make a shirt, we could have made 1 computer. So the opportunity cost in each case is 1 over 1, and the reciprocal of that is the same. All right, but now we're going to look and see who has the lower opportunity cost for computers. That's the U.S. Who has the lower opportunity cost for shirts? That's Mexico, and that tells us what each country should lean more towards, should specialize in, and then we'll see how much we can gain in output, and then through trade, how each country can get more of each good. Okay, so to start off, to do a comparison based on specialization and trade, we're going to always start off, and in these problems we'll work on proving this in many different situations. We always start off in what we call autarky. Autarky in economics means doing it by yourself, going alone. If you want to think about the derivation of the term, it would be from auto, which is self, archy, which is something like rule or governance. So you're self-rule or self-sufficient, self-governing in the production of all the goods. That means you're doing everything by yourself and not trading. So we'll always start off with autarky as the baseline and then compare the results we get with specialization and trade to that baseline scenario. So we always have to fix the resources to make this a fair comparison. Remember, in the Lego example, we had an hour in each case. If I would have increased the amount of time allowed, then of course I could have got more production. The cool thing about this is we can get more production in the same amount of time or with the same amount of resources. In this case, we're fixing our labor allocation. We have a total of 24 units or 24 hours for each country. And in the examples we'll work later, we'll see that I like to think in terms of dollars, because dollars kind of represent all resources. You can spend dollars and get land, labor, or capital. But either way, we'll see we're fixed at 24 total hours for each country. And in Autarky, it's usually easiest to just divide those resources up 50-50 or half and half to each good. So here, what this notation means is we've got 12 of the 12 of the labor hours going into computers in Mexico and 12 into shirts. Same thing in the US. 12 go into computers, 12 go into shirts. So then what production do we get out of that? Well, in Mexico, it takes 12 hours to make a computer. We've got 12 hours in computers, so we get one computer. And remember, in Mexico, it takes 2 hours to make a shirt. We've got 12 hours, so we get 6 shirts. Used up all of our labor, which we want to do. We don't want to leave any resources idle. In the US, it takes 1 hour to make either good. We've got 12 hours going towards both goods, so we've got 12 and 12, using all 24 of our hours. And then we want to look at the grand total, the world total down here. We just add up the total production for each country. We've got 13 computers total and 18 shirts total. So that's what we're comparing to. These are the numbers we want to beat when we use specialization. There's a lot of mixes, if you will, of reallocating the labor between computers and shirts that'll work. We'll just pick one here and go with it. And what we'll do, much like the Legos example, we're going to have the less bad player just go all out to their comparative advantage. So Mexico's going to take all of their labor and put it into shirts, none of it into computers. And so 24 hours of labor, all going into shirts, they make 12 shirts, and they've used all 24 hours. The US is just going to shift a little bit, and this is kind of like the dad in the Lego example. Still going to do some production of shirts, but going to shift a little bit into computers. So now we're doing 14 hours in computers and 10 into shirts. And at the labor cost of 1, we get 14 computers and 10 shirts for a grand total of 22 shirts, 14 computers. Now, remember I said the numbers to beat up above were 13 and 18. And we do indeed do that. We're plus 1 when it comes to computers. Okay, so the world has more computers, so that's pretty cool. And we're plus 4 when it comes to shirts. So the world has more shirts. That's pretty cool. And notice here that if the US goes all out, let's say the US did 24 computers and no shirts, we'd only have 0 shirts and we'd have 24 computers. Well, in that case, we'd be plus 11 computers, but we'd actually be down. We'd only have the 12 shirts of Mexico, and we'd actually be minus 6. So that's why the US still has to do some shirt making, because we want to beat both of those numbers. We want more of everything. That's always the standard that we're looking to achieve in these kind of problems. So when the US just shifts a little bit, we still get more shirts than we would have otherwise had, and more computers. Now the only thing to do is say, how can both countries benefit? Because here Mexico doesn't have any computers now, and they've got a bunch of shirts laying around. The US has some of each, but we want more than we had in Autarky. So how do we work that out? Well, I'm going to make a new table here. The textbook doesn't do this step, but I think it's really useful to understand how this works. I want to put each country down here, US and Mexico. And I kind of want to think about moving from autarky to specialization. Each country is going to have more of one of the goods. And I like to label this the extra good. And then the other one they shifted away from, and so they're lacking. I'm going to say they have an extra good and a lacking good in specialization as compared to autarky. If I go back to specialization, and we'll think about the United States first. What's our extra good? Well, the US is making more computers, 14 here, than we did in autarky, 12 here. So we have 2 extra computers in the US than we did in autarky. I'm going to say plus 2 computers. So we can say the US can trade away up to 2 computers. Of course, they'd prefer to trade less than them. Less than 2. Only 1 maybe. Okay, less than or equal to 2 computers is what the U.S. can trade away to Mexico, and they'll still be happy with the amount of computers they have. They'll still be equal to or greater than what they were in autarky. Okay, now let's think about the lacking good for the U.S. The U.S. in specialization only makes 10 shirts. In autarky, we made 12, so we're down 2 shirts. So we'd like to get those shirts back. So you can say -2 here. And we need at least 2 shirts. So we can say in trade-wise, we're going to say we want at least 2, greater than or equal to 2. So let's do the same thing for Mexico. In specialization, Mexico goes all out and makes 12 shirts, whereas in autarky, they only made 6. So Mexico's got 6 extra shirts now in specialization that they could trade away and still have the number of shirts they started with. So I'll say +6 shirts. Okay, and they're willing to trade away up to 6 of those. Of course, trading away less of them would be better. And then they're lacking computers. They have none now, and they had 1 in autarky. So they want to get at least 1 computer back. So I'll say greater than or equal to 1 computer. Okay, and now we can think about trade ratios. Okay, look at computers first off. The U.S. has an extra 2, up to 2. Mexico needs at least 1. So we want to kind of pair these together and say anything between 1 and 2 is going to traded from the U.S. to Mexico is going to leave both countries better off than they were in autarky. So in our exercise, we pick 1. In my exercises, I like to have each country have strictly more of each good. So I would maybe say something like 1.5. Of course, it's hard to trade a fractional unit of a computer, but nonetheless, we'll go with 1. Okay, and in the direction of trade, notice that that's going from the U.S. to Mexico, because the U.S. has extras of that and Mexico's lacking that. So that's going from the U.S. to Mexico. Now what about shirts? Mexico has an extra 6. The U.S. needs at least 2. So how many shirts are going to go from Mexico to the U.S.? I think in the example here we pick 3 shirts. Okay, so we're going to trade 1 computer for 3 shirts, right? Or vice versa. This is what the U.S. is giving, U.S. gets. Or from Mexico's perspective, it's going this way. Mexico gives, Mexico gets. And let's see how both countries wind up. Mexico's got its 1 computer back, so they were equal to where they started. So they're +0 here. That's fine. They're where they started. But now they've got 9 shirts. Even after trading away 3 of them, they still got 3 more than they did in autarky. So we're happy there. Okay, we're happy here. Not as happy. I mean, this is a really big smile here. We've got more. But here we've got where we started, so we're happy. So it's all smiles here. And the U.S. has an extra computer. That's 1 more than we had in autarky. Even after trading 1, we still have 1 more. So the U.S. is really happy there. And 1 more shirt than we had in autarky. So it's all smiles there. And notice the total consumption here, 14 and 22, it has to match the total production we did in specialization, which it does. Okay, so we're taking that extra production we have from autarky and we're dividing it up through trade amongst the countries, and everyone's got more than or equal to of both goods. And as I mentioned in my examples and the problems we'll work in this class, we'll make it so every country has more of everything. We're going to make these smiles really big all around. Okay, now the really cool thing about this, and we'll close on this, and then in the next video we'll just practice so we all get this down. And so it's really second nature for us because, as Paul Samuelson said, the math is solid, but still people are going to be suspicious and they're not going to want to believe in this, or they're not going to want to apply it in reality. People are so suspicious and skeptical of free trade. So I want to really drill this down. I want us to know, hey, the math is solid. You cannot deny that this gives everybody more of everything. So why would anybody be opposed to that? And we will talk about that in a forthcoming lecture. But here's the really cool thing. We got more of both goods. We got more of everything. And we're using the exact same resources. The same amount of land, labor, and capital, the same amount of time, the same technology. Okay, I did not secretly improve technology in the manufacture of these products. I did not secretly add workers. I did not secretly give them more time. The exact same resources gives us more of everything. Well, that's amazing. That's like a miracle. Okay? Normally in economics, when we talk about growth, we're talking about adding workers and adding technology. and becoming more efficient. Here we just did it through specialization. This is the most powerful concept in all of economics. Just by specializing in our comparative advantages, we have more of everything. Hallelujah. Thanks be to God. This is the greatest blessing we could imagine. Okay. So when I think about specialization, comparative advantage, and trade, it is all smiles. This is the coolest thing in economics.